by being the third generation, having the honor and the responsibility of leading this amazing institute, it's of course something that you have to take with a certain lightness. Otherwise, you will really feel the load of it, and I rather prefer to take it with lightness. And I decided in this presentation, being the last before the podium discussion, not to show any direct pictures of Frei Otto, because I believe that, and this is actually what it happened, that all of us have been referring and showing IL volumes and all of what has been inspiring us. And actually, to me, it was exactly the same. So I'm not going to show any image, but I will tell that I was in Bologna writing my thesis that was about shell structures. And I started looking there and finding there the IL volumes. I thought, oh, that should be an amazing space. What kind of crazy guys and ladies are working there? And I thought, actually, I want to belong to this group. And there is something that eventually it's not known to a lot of people. The first person I met was George ILEK. And he told me, that was 2000, he told me, I met him in Spain. And he told me, okay, look, it's my last year here at the university, so I think it's interesting what you would like to work on, and but talk to my pre-designated successor, that was Werner Sobek, and so everything started. And yeah, you can see 25 years later, I'm here in a different position, and I'm really enjoying that. And yet we have to find answers to different challenges, and this is actually the way that this symposium has been thought. So my overall tribute to Frei Otto, and this time, is this symposium itself, the way it has been thought, built, and it's great that everybody has been addressing that. Lightweight construction beyond mass reduction is something that Akim, but also other people have been already starting addressing and mentioning. And it is about going beyond the classical, traditional way of looking at mass reduction, even if there is a sustainable core in doing that, and face issues like climate neutrality, or getting even better, because it is possible to get better than just being neutral. I don't need to tell it here. And raising the level of circularity. And the great thing is that we have a big leverage as an industry field. And the bad news is that we are far beyond where we should be. So this is what it motivates to carry this discussion. So more than just having lightweight construction as a target, the overall agenda at the ILEK is a light ecological footprint. Now, for the people that deal with optimization issues, and there are a couple of very esteemed experts of that field, that means a multi-parameter optimization. And I'm sure there will be some discussion at the end. There's no Q&A, but there's going to be a podium discussion, so you can expand on that. And now the question is, how can you balance the need to reduce mass with a balance to reduce CO2 emissions with the need to raise the level of circularity? And this is the agenda, and this is the target. So each of the projects of the research work that we carry here at the Institute, they have to fulfill all the three. Jenny was attending one of our PhD discussion, and the very first question was, what is your research idea doing to contribute to all the three? Typically, if a researcher is discussing with me and I see there is one of the three which is not addressed, I say, take 1 week and come again, because this is not what we are going to do. And this is the other part of doing, having such a wide field, not being dedicated to one material, not being dedicated or committed to one technology. You have a lot of freedom, and the question is how you deal with this freedom, and how you still keep focused, even if you have a very wide field of possible application. Before I go into the three main line of researchers, of course, we've been clustering research ideas into groups dealing with such a freedom. I would like to talk a little bit about the link to the practice. And this is related to your quote of Hakim, actually. I think we are all driving in a similar direction. How relevant it is that we bring innovation to the practice in terms of researchers, but how relevant it is that in the practice we do carry innovation. And so there's a very, very special characteristic to not only to the University of Stuttgart, but I would say here it has a very special weight, is the fact that there is a long tradition about linking together research and practice. I mean, Fritz Leonard has been mentioned already, Josh Leich. There is a strong tradition of people pushing in both directions and kind of transferring ideas back and forth. And I still believe this is essential. Essential for the practice, essential for the research. And so allow me just 2 minutes maximum, I'm checking, to show a couple of the projects I was doing, because that is the background and that bring to me the, also this is getting tired, that's bringing to me the ideas and the questions that are now part of my research agenda. So the first one is typical example of a pre-stressed facade. It's a pre-stressed structure, cable facade. As an Italian working for Ferrari as a brand, it was a chance. And what it was interesting is I was just a couple of years done with my study at Penn, having dealt with parametric, with GC, and with all these ideas. And I said, why don't we build this skin with a parametric approach? And we've been working with a contractor. It's all double curved. Before that, I was talking with Arnold and learning about how he was facing the Mercedes Museum. So there was kind of contamination on that. And this is a mix of lightweight design on one side and parametric design and engineering and fabrication on the other side. So I brought my two experiences, the one in Stuttgart and the other at Penn, done together in this first project. That was one of my first projects. Totally different project. Museum of the European History, some years later in Belgium. Here, the understanding of lightweight, in my view, is totally different. It is about preserving an existing historical building out of the 20th century and still making it fit for a completely new use. It was a dental clinic, and it became a museum for European history. And being that, it was important to raise the level of transparency. And you can bring the two together without having to tear it down, but just integrating the two aspects together. In my understanding of extending the field of lightweight, this is lightweight, even if it's done with masonry, because you are not tearing the masonry down. And of course, there is kind of more traditional lightweight, similar to what Mick has been showing before in the way we deal with the detailing and make it clean and minimalistic. So it's a mix of traditional lightweight and extended lightweight construction. I'm not going to spend time on that, but one of the reasons I've been asked to develop the digital process for this project, it was because I was coming out of such an experience as Ferrari and trying to bring this idea of parametric approach to design and fabrication to a concrete structure. And that's about it. I'm not going to expand it any further about that, but I think it's important to have this space of exploration and to be able to bring that with all the constraints to the practice. And that was the basis, wrong sequence? No, that was the basis for the next generation. The next generation is a parametric design from Foster and Partners with pretty big shell roof, and I think we all agree in this space, or most of us at least, that shell structures are a very, very efficient system. And one of the issues about building shell structures nowadays is the formwork and the scaffolding on top of the formwork. So here we don't have scaffolding, and actually we have just adaptive formworks. And there is a big effort of doing parametric engineering up to fabrication next to the site. So the 37,000 panels out of concrete, this time I'm telling you 16 centimeters, and this shell has a 100-meter span. There's a trick about it I'm going to tell you right away. They've been produced right next to it. And so this is a 0-kilometer fabrication. The shop has been dismantled already. You cannot see it anymore. The concrete structure is complete. No waste out of the formwork. Just adaptive hydraulic cylinder generating the form. It is economic for that kind of building. Now, of course, we can argue and question, is that a one-of-a-kind structure? I think it's something that can be discussed later on. Can we bring this, reduce the level of complexity and bring it to other kind of projects? I believe yes. But these projects have the legitimation, and because they allow us to develop solutions and methods that can be done later on, reduced and applied to simpler things where there is not the frame, at least not the financial frame to deal with that. We didn't have the time frame to make that much development. So this is just to provide the background and the link to the practice. And now you may see some out of the research why we do certain things the way we do them. So the first line of research is about adaptive systems. And I took this picture from the US when I was in Utah. And of course, nobody is hoping to get as extreme in terms of climate change. But the other side is that we really can learn from nature how we can react even to such extreme conditions. And one thing is sure, we have to be much more transformative in the way we approach architecture. We have to be much more adaptive. It's something that Jenny has been already touching on. And this is something that we've been addressing in our Cooperative Research Center 1244 or SFB 1244, depending if you are thinking it in German or in English. And I think most of you have been already seeing the tower, but I know some of you have not. So I'm showing the video how the tower can move. And this is not just about making a tower to move, because this is fancy. It is about the fact that we can save more than 50% of the structural mass by reacting, by making such a structure flexible and reacting to wind or earthquake or extraordinary condition by additional smartness of the system. And there are a lot of researchers coming from different disciplines working on. So I think I don't need to tell that this is, of course, generating or is laying on the interdisciplinary way that was opened by Frei Otto and all the network of researchers working with him. I mean, I think it's important, and I hope it has been visible, that it's not only about Frei Otto. He was a charismatic person, but there were great researchers coming together, and all of them together make this possible. Yeah, so it's important also to outline the relevance of the network. And beyond that, it's important for me to outline the relevance on the industrial partner out of this, what it is, a fundamental research project, which usually is something that when you have the DFG listening to it, you wouldn't like to show, because that means you are not doing any fundamental research. Now, it's something I'm willing to challenge and question, because it is possible to do fundamental research, and it is possible to have, and the cluster is also following a similar strategy, and it is possible to have an association with industrial partners to speed up the transformation and the transfer of ideas, not all of them, but part of them, into the practice. And so it's great to have all the different shareholders on board. Now, It is a technological project, but to me, the tower, which is, as I was saying before, it's a NEPA selected project. It's much more than just the development of technologies or methods. It is a paradigm how we can make our architecture much more transformative. And the great thing about this design is that we can take down every single element, a column, a slab, they are made out of wood, a facade made out of textile. I'm stressing intentionally the fact we are working with different materials because I think it is essential in my way of understanding lightweight today and tomorrow. And by doing that, we can keep transforming this tower. So it's a building which is evolving over time. And when I started here 5 years ago, it was looking more or less like that, 1 year later, to be honest. And you've seen yesterday, it's much more than that now. It's starting getting populated with different skins. And every floor has a different topic. Now we are discussing with Jenny about the 7th floor, for instance. And the idea is to have a catalog of different solutions. But beyond that, the idea is to show how plural and transformative our architecture should be. So it's once again, I'm quoting, it's not about a style, it's about an approach to the way we understand architecture. And we do like to involve our students in this kind of thinking. And so one of the first projects we did with our students, and we do like to have architecture and engineering students together, I still believe it is key, is to say, now we have 1 floor of facade, 60 square meters tensile, we have timber, what can we do out of it? And I think all of you have been enjoying, or most of you have been enjoying the catering outside. And so this is what we developed together with the students. No costs, just brain and a bit of time and creativity. This is essential, of course. And if we look into other possible areas of application of this approach, then of course we have to look at infrastructures as well. And if we see and think about bridges which are collapsing or bridging which are coming at the end of their life, then the ideas of monitoring real-time behavior of this system and the idea of manipulating the forces and the structural behavior can apply pretty well actually into this realm as well. So this is also part of our work. Now, this was about what we do and what we are keeping doing in terms of adaptive structures. But we want to focus also on adaptive skins. And there are several reasons why we are doing that. Because if you look at, first, it is the background of my personal background, the tradition of the space over the last decades. But secondly, it's about the impact of structures and skins in the way we use the resources, in the way we interact with people. And that's at the end of the day about it. And the question is now, what kind of skins are we looking for? Are we looking into skins which are kind of stiff boundaries between inside and outside? The term porosity has been already used. We both have been discussing that as you were here. And to me, skins have to be porous, but also in a way they engage resources and they see the natural environment. There's been also discussion about, are we part of the natural environment? I believe yes. And how do you engage the resources? So we do look into adaptive way of reacting to solar radiation. We do look into ways of change the forms of our elements to raise the level of harvesting energy. Do look by changing in a different way the inclination of the lower wings into way of reacting to the comfort needs of people and addressing their glare needs. Different aspects that are brought together. And we do look into ways how we can use this dynamic character of the skins in a kind of playful way, having people touching the skin and feeling there is something happening there. So there should be also a level of fun into doing this kind of works. And we do see rain as a resource, and so we collect with a project Hydroskin rainwater, and we can use it in a decentralized way. So we don't have problems with canalization, and we do use the resource. And then through cooling, evaporative cooling, we can cool down the environment. So a skin which is really in a kind of osmotic behavior between inside and outside space. And we do explore these ideas and furthermore with our students. These are just a choice of our booklet out of our ILEK lab 1244, which is in a way our way of addressing the questions out of the research in a design way together with the students. And I think it's important to acknowledge that and to acknowledge how the relevance of it. So these are the two main fields related to adaptivity. And now this image is not that far away from you, Jenny. It's not a case that both of us are at the end. And the question is about here, the third field of research, mineral materials. So as I was saying, we don't commit to one single material. However, we have a commitment to mineral material just because we do believe that since they are so wide used in the practice, if we change our way of dealing with that, we have a much bigger impact. That means we bring together the idea of lightweight in an extended way and mineral materials, and we engage them in a different way. So this is the target of the third field of research. And so we do use different technologies. I'm bringing now the next or degraded concrete technology, which has been developed before my time by Werner Sobeck, to the next level. And so out of these holospheres, which you can see actually at the entrance, and you can take it in your hand, we've been making all the checks in order to be sure that this technology can now be used in the cluster building that Hakim is responsible for, and where we are taking care of the concrete part. And by doing that, of course, we address the reduce issue and the recycle issues, because these holospheres are on a mineral based. But is that enough? It is not. We should keep considering ways of increasing the level of reuse of concrete, which would mean not crushing it down and recycle then some of the components, would mean cut it down, generate segments out of it, and then bringing them back together. So you may see a certain reference to the work we did in Kuwait, but in this time it's not about a shell, it's about generating a segmented slab system and solution. It's a PhD research. And so at the end of the day, we will hopefully very soon see these two first levels done, executed, and then we can show how that transfer has been really working in vivo. You said, Hakim, yeah? It's working well. And behind that, it is about making this porosity visible. There is a beauty about that, and concrete mineral materials can actually reach this level. And of course, in order to do that, we have to engage technology and methods of our time here, topology optimization. And what it is also important, we have to find ways of using new sustainable formwork. In this case, is sand. It was Daria, PhD. And in this case, we use carbon fibers. And then we've been discussing about the next generation. This has been, the Marinaressa was shown 2 years ago in Venice within the frame of the Biennale. And now the next generation is shown in Vienna at the Technical Museum, and is showing both technologies that I was talking about, but it's also showing something on top of it, the use of a different kind of reinforcement made out of basalt. So that means that we can have, we need something for this porous system, which has more a fiber character. Now you have a link again to the fiber word, if you want, in a different way. And basalt is a volcanic based material, so it's fitting much better to the idea of recycling and using a monomineral logic. And beyond that, it's a great fire resistance. And so we're starting developing then ductworks out of basalt with ceramic matrix, for instance, where we can use the fire resistance of this system, and we can use this element as an additional reinforcing element. And at the end of this, we are looking, and now biology is coming back, there's going to be a bit more about that. We are looking into ways of substituting cement into mineral-based material, because cement, as we know, is the one component driving CO2 production. So what about if we have bacteria generating the binding character, in this case, by creating calcium carbonate crystals? And what you see here are sun grains, which are linked together by the crystals which are generated by the bacteria. So in this case, the bacteria are coagents. And we've been demonstrating that we can achieve a high strength, 50 megapascal have been already demonstrated. We can use 3D printing technology, and so we can have a porous system which is made out of a material which has a low ecological impact. And this is where things come together. So you see we are widening the field, but we are looking into ways of raising the level of or diminishing the ecological footprint of our contributions. And now, of course, you expect probably from me the question, what is next? What is the agenda for the coming years? It's 5 years I'm here. I still hope I will have further years to develop certain things. And I decided, when I was thinking the future is pretty unsharp in my mind, I decided to take these pictures, which is actually a picture taken exactly from the shell 20-something years ago, I think 21 years ago, when I was experimenting about the optical qualities of these double curved glasses. And to me, what it is next is related to my experience in Brussels. And it is about working much more into the existing buildings. It is about finding ways of avoiding these buildings to be teared down. What you see here is actually the building down there, and it was intended to be demolished. And we said, look, they decided not to demolish for several reasons. And we said, okay, why cannot we make an experimental work out of that and develop new skins that we can bring it to the existing building, we can upgrade it in such a way that you can, in 20 years, 30 years, dismantle it again and without generating any waste. So there is a link to what I've been presenting before, and this is actually the vision behind it. No waste generated out of a snake skin, and this is actually where we want to go. And what I would like to mention is, as a further line, is the will to enforce the idea of circularity with a new lab, which we will call the ILEK Circular Lab. This is a project you've been able to see, I hope. If not, you can go outside later on and see. It's a collaboration with Mariana. Mariana showed how it was in Bruges. And so my question when we discussed about that was, it's great to have such a membrane, but can we bring it to be a different form? Can we activate the creativity once again? Can we do something different out of it and show how flexible we can deal with existing materials? It's not just about patchworking, nothing against patchwork, but it goes beyond that. And of course, it is a paradigm of the way I do understand the role of the ILEK also in the future, as we engage collaboration with Jenny, we engage collaboration with Mariana. I see how out of the challenges we have to face, and I'm going to show this picture once again, that we have to get a stronger network, just because facing all the three together, it's a pretty ambitious agenda. So everybody who is interested in working on a light ecological footprint is, of course, invited to join forces. I think we need all of our brains and capacities. And we need, and I want to outline that, we need, of course, a motivated team. And I believe you've been experiencing already how motivated the team here is, joined also by the team out of the IFAC. And I just want to acknowledge that, of course, all of this, what I've been showing, it's teamwork. And actually, the idea is to expand this idea of a team than in a network where you put even more persons. And I want to thank everybody who is going to willing to go this way with us. Thank you.